Think back to your first physics class. A block sits on a table. An arrow points to the right. Force. Another arrow points down. Gravity. The teacher says something like, forces cause motion. Push harder, more motion. Pull things move toward you. Stop pushing, motion stops. Clean. Mechanical. Intuitive. And almost completely wrong. Not useless wrong, but conceptually misleading in a way that follows you for years. Because the truth is far stranger. Backhand index pointing right forces do not act the way school teaches them. Backhand index pointing right nothing is actually being pushed or pulled the way you imagine. And once you see this, arrows on free body diagrams start to feel like cave drawings. The picture we're given and why it feels so convincing. In school, forces are taught like invisible hands. Gravity pulls downward. Magnets pull metal. Springs push back. Friction resists motion. Everything is framed as Object A applies a force to Object B. That language feels natural because it mirrors human experience. We push doors. We pull ropes. We feel resistance. So physics borrows that intuition and says, nature works the same way. But that's where the lie begins. Because at the fundamental level, there are no pushes. There are no pulls. There are no invisible hands. The question that breaks the model. Here's the question school never asks. How does a force cross empty space? Take gravity. The earth pulls you downward. Okay, but how? There's no rope connecting you to the center of the earth. No physical contact. No mechanism reaching across space. Just distance. So what exactly is doing the pulling? Most explanations quietly dodge this by saying, the earth exerts a gravitational force. That's not an explanation. That's a label. It's like saying, opium makes people sleepy because it has a dormitive virtue. You've renamed the mystery, not solved it. Newton got the math right, but the picture wrong. To be fair, Newton's laws work incredibly well. They predict motion. They build bridges. They land spacecraft. But even Newton knew something was off. He famously disliked the idea of gravity acting at a distance. He called it so great an absurdity that no one with philosophical sense should accept it. And he was right to be uncomfortable, because gravity doesn't pull the way ropes pull, and neither do any other forces. What modern physics quietly admits. Here's the uncomfortable truth modern physics has learned. Forces are not causes. They are descriptions. They don't explain why something moves. They summarize how motion changes under certain conditions. In other words, forces are bookkeeping tools. They're useful. They're precise. They're not fundamental. And once you see that, the entire push-pull picture collapses. Motion doesn't come from being pushed. Let's take the simplest case. A ball rolling across the floor. School says, the force from your hand caused the motion. But look closer. Your hand was only in contact briefly. After that, the ball keeps moving. No force continues pushing it forward. In fact, in the absence of friction, it would keep moving forever. So what actually caused the motion? Nothing. That's not a trick answer. Motion doesn't need a cause. Change in motion does. Acceleration needs explanation. Velocity does not. That single idea already contradicts how forces are taught. Forces don't make things move. They explain why motion changes. This is subtle but critical. Forces do not create motion. They describe constraints on possible motion. They tell you how paths curve, how speeds change, which configurations are unstable. But the motion itself is not being pushed into existence. This is why modern physics increasingly avoids force language when possible. Instead, it talks about energy, fields, geometry, constraints, because those are closer to what's actually happening. The field trick and why it still isn't the truth. At some point, physics classes upgrade the story. Forces don't act directly. They act through fields. gravitational fields, electric fields, magnetic fields. That sounds deeper, but it still sneaks in the same mistake. Because now we have to ask, what does a field actually do? Does it push? Does it pull? Does it reach out? No, a field is not a thing acting on objects. It's a map. It tells you how space is structured. Given this position, given this velocity, this is how motion will evolve. Nothing is being touched. Nothing is being grabbed. The object simply follows the rules of the landscape it's in. Gravity is the cleanest example of the lie. Einstein finally said the quiet part out loud. Gravity is not a force at all. It's geometry. Mass bend space-time. Objects follow the straightest possible paths in that curved geometry. The Earth is not pulling you down. You're moving straight through curved space-time. The ground pushes up on you. That's the real force. Gravity? No force required. And once you accept that, you have to ask an uncomfortable question. If gravity isn't really a force, how many of the others are lying too? Electromagnetism isn't pushing either. Take electric forces. Like charges repel, opposite charges attract. That's the story. But again, how? There's no contact. No collision. No job. What's actually happening is this. Charges modify the structure of space around them. Other charges respond by following allowed paths. The motion minimizes energy. No push, no pull. Just a system sliding toward stability. Forces are gradients, not agents. Here's the sentence that replaces everything you were taught. A force is not something that acts. It is something that points downhill. Mathematically, forces are gradients of energy. They tell you which direction reduces energy fastest. That's it. No intention, no mechanism, no pushing. A ball rolls downhill not because the valley pulls it, but because higher positions cannot persist. The same logic applies everywhere. Why school teaches it the wrong way? At this point you might ask, if this is so wrong, why teach forces at all? Because forces are useful lies. They compress deep ideas into something calculable. They let beginners solve problems without learning differential geometry, field theory, or variational principles. But the cost of that shortcut is intuition. You leave school thinking, forces are things. They act on objects. They cause motion. And that mental model quietly breaks everything that comes later. The hidden rule beneath all forces. Underneath every force, there is the same rule. Certain configurations of a system are unstable. Nature doesn't push systems away from instability. Instability simply doesn't last. Motion is what remains. Once you see this, forces stop feeling like causes and start feeling like symptoms. A question to let sit. So here's the question to leave hanging. If forces don't actually push or pull, if fields are maps, not hands, if motion comes from geometry and energy, not interaction, then what are we really calculating when we draw arrows on objects? In the next part, we'll strip forces down even further, past gravity and electromagnetism, and see why modern physics increasingly replaces forces with principles, constraints, and extremes, and why the universe seems to care less about causes and more about what is allowed. That's where the force story finally breaks. By now, the word force should feel suspicious, not useless, not incorrect in calculations, but deeply misleading. We started with the classroom picture, arrows pushing boxes, pulls across space, invisible hands acting on objects. And one by one, those images collapsed. Gravity isn't a pull. Fields don't act. Objects aren't shoved into motion. So now we arrive at the only question that matters. If forces don't really push or pull anything, why does the universe still move the way it does? The answer is simpler and stranger than any arrow diagram ever suggested. The universe doesn't ask what caused this. At the deepest level, physics doesn't ask, what force caused this motion? That's a human question, a narrative question, a question built for intention and agency. The universe asks a different question entirely. Which configurations are allowed? And, just as importantly, which ones can't last? Motion is not produced. It's left behind when instability disappears. Forces are shadows of something deeper. Here's the cleanest way to say it. Forces are not fundamental ingredients of reality. They are summaries of deeper constraints. They emerge when you describe motion in a certain language. Change the language, and the forces vanish. This isn't philosophical wordplay. It's exactly what modern physics does. Energy comes first, always. At the core of almost every physical theory is energy. Not as fuel, not as substance, but as a bookkeeping system for what can happen. Every system has possible configurations. Some configurations store more energy. Some store less. Some are forbidden entirely. What we call motion is just the system evolving away from unstable configurations towards stable ones. No push required. Why downhill explains everything. A ball rolling downhill is the simplest example, but not because gravity pulls it. The key is this. High-energy configurations don't persist. A ball perched on a slope occupies an unstable configuration. There are many nearby configurations with lower energy. So the system changes. The ball moves, not because something forces it to, but because staying put is not allowed. That same logic applies everywhere. Forces are just energy gradients in disguise. Mathematically, a force is the gradient of energy. That sounds abstract, but the meaning is simple. A force tells you which direction energy decreases fastest. That's it. It doesn't cause motion. It points to instability. Once you see that, the entire push-pull idea dissolves. Forces don't act on objects. Objects follow energy landscapes. Why geometry replaced gravity? Einstein didn't reinterpret gravity for aesthetic reasons. He removed it because it wasn't fundamental. Gravity as force was a workaround, a useful fiction. Space-time curvature, on the other hand, does real explanatory work. Objects don't fall because they're pulled. They fall because the straightest possible paths through space-time happen to converge. No force needed. Gravity disappeared, and nothing broke. That should tell you something. Electromagnetism isn't an exception. You might think electromagnetism is different. Charges repel. Opposites attract. That feels force-like. But dig deeper, and the same pattern appears. Charges alter the structure of the electromagnetic field. That field defines which motions are stable. Other charges respond by following those allowed paths. Again, no pushing, no pulling, no contact across space. Just constraints and consistency. Even contact forces aren't forces. What about normal force? Friction? Surely those are real pushes. Except they aren't. When a table pushes back on your hand, nothing is exerting a force in the intuitive sense. What's happening is, electrons resist overlap. Quantum states become forbidden. Energy rises sharply. Your hand stops because the configuration cannot continue. The force is a description of that resistance, not its cause. The principle that replaces all forces. Modern physics increasingly uses a very different starting point. The principle of least action. It says, out of all possible paths a system could take, the one that actually occurs is the one that extremizes a certain quantity called action. No forces, no pushis, no causes, just selection. Reality doesn't ask what acted. It asks which path is allowed. And the answer is built into the structure of space and time. Why this feels so backward? This way of thinking feels wrong at first because it reverses causality. We're used to thinking cause-effect, force motion. But fundamental physics often works like this. Constraints allowed paths motion. Nothing is driving the system forward. Unstable options simply disappear. What remains is motion. The universe is not dynamic, it's selective. Here's the quiet, unsettling shift. The universe doesn't do things. It permits things. It doesn't push objects around. It defines which configurations can exist. And motion is what happens when the current configuration isn't one of them. That's why this perspective works everywhere, from falling apples to orbiting galaxies to quantum particles. Why forces still appear in equations? At this point, you might wonder, if forces aren't real, why do physicists still use them? Because they're incredibly convenient. Forces are compressed descriptions of constraints. They let us calculate without rebuilding the universe from scratch every time. They're approximations that work extremely well in limited domains. But mistaking them for reality is like mistaking a map for the territory. The mistake school never warned you about. The real problem isn't that forces are taught. It's that students are never told. This is a model. It is not what's actually happening. So the arrows sink in. The intuition hardens. And later, when students encounter relativity, quantum mechanics, or field theory, everything feels contradictory. Because they're still thinking in terms of pushes and pulls. What replaces the old picture? Here's the picture that actually survives modern physics. Space has structure. Time has direction. Energy defines stability. Constraints define motion. Objects don't interact by force. They coexist within a rule-bound landscape. Motion is what happens when a present arrangement can't stay. Why this makes the universe more impressive, not less. Some people hear this and feel disappointed. No forces, no causes, no invisible hands. Just rules? Yes. And that's precisely what makes it astonishing. The universe doesn't need effort. It doesn't need intention. It doesn't need intervention. Once the rules exist, everything else follows, perfectly, endlessly, without exception. Stars burn, planets orbit, atoms bond. You breathe, not because something pushes them to, but because nothing allows them not to. Why we'll still say force tomorrow? Tomorrow, engineers will calculate forces. Physicists will write F equals ma. Teachers will draw arrows. And that's fine. Forces are a useful language. But now, behind the language, you know the truth. No push, no pull, no agent acting across space. Just energy landscapes, geometry, and forbidden states. The final shift. So here's the thought to take with you. The one that replaces the classroom picture entirely. The universe is not a machine being pushed from moment to moment. It is a structure where some states cannot exist. Motion is not caused. It is what remains when instability disappears. Forces don't make things happen. They describe how impossible things fail to persist. And once you see that, the universe doesn't feel colder or emptier. It feels quieter, cleaner, and far more profound. Because nothing needs to be forced. For everything to move exactly the way it does.